Let's start to configure site-to-site IPsec VPN between two Cisco router using IKEv version 1. This is our lab topology. We have R1 and R2. R1 is HQ site and this is a remote branch. R1 public IP is 1.1.1.1, which I mentioned here, and private IP we will assign 192.168.1.1. 32 is the subnet mask because we're going to use loopback interface to represent our private IP. On this side we have R2, public IP is 2.2.2.2 and private IP is 192.168.2.2. In the middle we have ISP Internet Service Provider, which is also a router. The router image which is used in this lab is this one. IPsec protocol which we will use is ESP, which we discussed theoretically. First, we need the basic configuration of R1. Basic configuration such as host name, public IP, private IP, and default route to send the traffic to ISP, which we normally configure on edge router and firewall. After that, we're gonna configure R2, the basic stuff. Then the ISP has two interfaces to configure. And finally, we're gonna start from R1, phase 1 configuration. We will configure the policy, authentication, encryption, group hash, lifetime, and the pre-share key. Similarly, we will configure phase 2, the interesting traffic. In this case, interesting traffic is our loopback interface 192.168.1.1 when the traffic is going to 192.168.2.2. After that, we will combine these in crypto map and assign the crypto map to the outgoing interface. In this case, 0/0. And the same thing we will apply on R2. This is what we want to configure. So let's start from R1. So let me click on R1, hit enter. There is no configuration, no. Let me open R2 as well, hit enter. And let's go to ISP as well and hit enter. Nothing is configured on these devices. So let's start to configure the basic stuff. So I will use the script. R1, go to enable configuration, change the host name, two interfaces and default route. So let me copy this one and paste. So R1 is done. Similarly, R2 basic configuration, two interfaces and default route. Copy and paste. ISP has only two interfaces to configure. So let's go back to ISP and let me copy this one and paste. I don't need ISP anymore, so let me close that one. And now I need R1 and R2. So this is R1 and we have R2 with basic configuration only. Okay, so let's start from R1. In R1, we're gonna start from crypto. And ISA-KMP means we are going to configure phase 1 and the policy. You can give any number to the policy, they will check all the policy. Anyway, let me give them 1. The simple way is just type question mark, it will show you each and everything. First, we need the authentication. How to authenticate? So let me type in question marks. We have two choices, certificate and pre-share key. So we're gonna use pre-share key to authenticate. After that, we need encryption. How to encrypt the data? We discuss all these things. For encryption, we have three choices, 3DS, AES and DES. AES is more secure. Anyway, in this case, we're gonna use 3DS. So authentication is done. Now we need Diffie-Hellman group. So let me type group and this router support these groups. So let's choose 2. And after that, we need the hash algorithm. So let me choose hash. For hashing, we have two choices, MD5 and SHA. SHA is in different flavor as well. So let me choose SHA in this case. And finally, the lifetime, for how long this tunnel will be. So let me type question mark and let me choose the default one, which is 1 day. And we are done with this policy. And let me exit from here. This is the way to configure. So if I type do show running and section crypto. Okay. So what we done, crypto is the IKEv policy 1, encryption is 3DS, authentication pre-share key group 2. While it's not showing the hashing because that one is the default one. So this why it's not showing, but this the first step we configure. Next thing, because we use pre-share key, let's configure the pre-share key. So crypto Isaac MP and I want the key. What will be the key? You can type a key. So let's type Cisco 12 and then the address. Address means it's asking the peer IP address. So our peer is, let's go to here. Our peer is 2.2.2.2. So let me type the IP address 2.2.2.2 and hit enter. So now I'm done with phase 1 of configuration. Okay, now we need to move on to configure phase 2. So let me clear the screen and let's try to configure phase 2. Crypto IPsec. Now I type IPsec. Previously I typed crypto Isaac MP, means I am interested in phase 1. Now I'm interested in phase 2. And they call them transform set. It gives them a one name so that you can combine each and everything. So we need to type transform set and name for this one. So let me give them tset1, whatever the name you can give them. In this case, I give them tset1. So we have two protocol which we discussed. We have AH and we have ESP. Because here we decide to use ESP, which is more secure, ESP. So I'm not interested in this section. I'm interested in ESP. Now for ESP, what will be the authentication and hashing? Similar like a phase 1. So I need to choose that one. So let me choose ESP AES. Then in AES, we have many flavor. Let's choose the first one, 128-bit. And question mark, now I need the hashing algorithm. So let's choose the MD5 one, HMAC. Let me choose this one and hit enter. So this is phase 2 detail, similar like a phase 1. So I choose ESP and AES and then MD5. And now exit from here. Next thing, I need the lifetime, similar like a phase 1 lifetime. I need phase 2 lifetime, tunnel lifetime. So let me type IPsec and then security association and lifetime, and then we have different choice for lifetime and days, kilobytes and second. Let's choose the second which we normally choose, and let me type anything whatever you like the duration of this phase 2 tunnel. So 3600, let me choose this one. So now phase 2 is also done, phase 1 and phase 2. Next thing which we require is the interesting traffic. Which traffic has to be encrypted when it's sent to the other side? So we choose 192.168.1.1 when it's going to 192.168.2.2, make them encrypted. This is called interesting traffic or ACL, interesting ACL. So we are done up to this point. Now we want to configure ACL for interesting traffic. So let's go to R1 and let me configure ACL for interesting traffic. So it's better to use IP access list extended one, and let me give them any name, suppose VPN VPN T1, whatever the name, suppose 1. Okay, you can give them any name, by the way. And let me say permit IP host. And what will be the host? So I need the host is this one. When single host, in this case, I'm going to use single host. It can be the entire network as well. Normally it's entire network. And I say that if this host is going to 2.2 host, which is this side, 2.2. This is my trusting traffic. Permit them and exit. So my VPN ACL is done. Next thing is the crypto map to combine. So I will type crypto map and I can give them any name. In this case, I will say CMap, suppose. CMap. And you can give them any sequence number up to 65535. So let me give them 10. Normally we start from 10. It's up to you. And then IPsec and IKEv1 means phase 1 and phase 2. IPsec is phase 2. IKEv1 is phase 1. It will show you a warning that you need an ACL. And valid ACL. We just create an ACL, which is this one. Crypto map will combine these things. So let me type match address. Address means the ACL. Our ACL name is this one, which is the interesting traffic. Next thing, you can type question mark to get the details, by the way. So match we are already done. Now set. Next thing is set peer. Who is your peer? So we already know our peer is 2.2.2.2. The other side. Public IP 2.2.2.2. Next thing is set transform set we require. So our transform set, which is the phase 2 name. So let's go up, and what was the phase 2 name at this one? Crypto IPsec transform set T set 1. And hit enter and exit. So crypto map is configured. Let me clear the screen. Finally, I need to attach this crypto map to the outgoing interface. So our outgoing interface is 0/0, Ethernet 0/0, and then crypto map. And what was the map name? We just configure. So let's go up, and it was somewhere here which we configure CMap, and attach this one and exit. This is the way to configure site to site VPN. So one side is done. Now the same thing has to be configured on the other side. Few things has to be changed. So what we can do? The simple way is to copy from here. We can type show crypto. It's better to type show running and type here section crypto. So we can copy from here, by the way. So let me copy all these things, and you can use a notepad. So let me open a new notepad and paste. So encryption will be 3DS, authentication pre-share key group 2. Okay. Hash is not showing because that is the default one. So we can type hash or cell, which is SHA. So hash is SHA, and then exit from here. So we have crypto map 3DS authentication group exit, and the key will be the only thing you need to change now the peer, because we are going to configure this side now. So I copy the script from here to save some time and just to show you how you can do it. So now the peer is 1.1.1.1. So what I will do, let's go back and just change this one thing, 1.1.1.1. Then leave the things here similar. By default mode is tunnel, that's why it's showing, but we never type this one. It's okay. Now crypto map, similar thing. Now I need to change the peer as well, 1.1.1.1. Leave the same things, set transforms T set, match this one, and now exit from here. And I need to go to the interface to attach. So here the interface is 0/0. It can be different, by the way, but in this case is similar. So interface is 0/0 and attach this crypto map. But one thing is missing, the interesting traffic. So what I can do for that, I can type show access list is better. So let me type ACL and copy from here. Okay. And let me copy. Either it's better to do it by another way. Show running section access list. It's better to do it like this. So copy, and let's go back to our notepad and put them somewhere here. It's better to put them here. Okay, and exit. But only thing, I need to make them mirror. So change this to 2 and this side 1 1, because now I'm going to configure this side. So the traffic will start from 2.2 going to 1.1. So I've done few changes. The peer IP, mirror the ACL, and peer IP. That's it. Rest of the thing you can keep them the same. So it's so easy to configure. And now copy this one and let's go to our R2 and just paste them. And this way you will save time. So let me go to config and let me paste, and we are done. So now both sides are configured. Now we need to test them. For testing, let's go back what we have done. So crypto map is assigned, then R2 to R1, we done the same steps, but I copy the script, by the way. Then phase 2, then interesting traffic, we reverse this one, mirror them. Then crypto map, we change the peer IP and then assign to the outgoing interface. To initiate the traffic, to check them, so we need to ping the two loopback interfaces, which we configure on both sides. And then we can use show crypto to verify phase 1, and we can type show crypto IPsec to verify phase 2. Here show crypto IKev1 to phase 1 verification, and show crypto IPsec anything to verify phase 2. Also, it's better to capture the packet. It's better. So right click here and let's go to capture and 0/0 interface. It will hit this interface. So we will see in the Wireshark as well. Not in detail, it will be in the next video, but however, at least that we can verify site to site VPN. So let me start this one. Okay. And let them start. Then I will start to generate traffic from R1 loopback interface to R2 loopback interface. Yeah, it's okay. And let me type here IKev1 to filter them by only this one first time. So there is no traffic. Let's go to R1. So show IP interface brief. We have this loopback interface ping, and I want to ping the other side 2.2 and make them source our 1.1. You get my point? From here this IP to the other side IP, and let's generate traffic. If everything is okay, one packet is lost, but it can ping now. It's okay. And let's go back. And here you can see 6 packet because you are using man mode. 1, 2, 3, 4, 5, 6 packet phase 1 and 1, 2, 3 packet of phase 2. I'm not going in detail. We will discuss this later on. After this 6 packet exchange and 3 packet exchange, then it will start ESP because you are using secure method to encrypt the traffic and send from 1.1 to 2.2, and it's here. Done this side. Now let's verify from CLI. Here I can type show crypto IKev1, and all these things can be verified using phase 1. Normally we say SA, security association. So here you can see that my destination is 2.2, my source is 1.1 public IPs. This is the status, connection ID, and it's active, and everything is working. Similarly, if you want to verify key, the key which we use is Cisco 1 2 pre-share key. If you want to verify the policy which we create is policy 1, where we use 3DS, hashing secure hash, authentication pre-share key, Diffie Hellman 2, and this is the lifetime of the phase 1. This phase 1 lifetime. Similarly, you can type all these to verify phase 1 detail, policy, profile, and essay. For phase 2, show crypto IPsec SA. And here it will show you that CMAP is applied to this interface. Local IP is 1.1. Local address is 192.168.1.1, which is our loopback. The subnet mask, protocol, and port. And the remote is 2.2. This is the subnet mask, protocol, and port. Port number 500 we discussed theoretically it's using. And you can see how many packet has been encapsulated, how many packet has been encrypted and digested, and also decompressed. It will show you those as well. So we just send only 4 packet. That's why it's showing you all the detail and other stuff as well. And because we are using ESP, so there is no inbound AH, and there is outbound ESP, and there will be inbound ESP. Okay, so it's inbound ESP, and here we have outbound ESP. This is phase 2 detail. We use AES, and these are the tunnel. These are other detail, crypto map, and replay detection is enabled. All those detail which you can verify. It's 4 packet, yeah. If you send more, let's send more from one loopback to another loopback, and it will be more now. So if I try again, so here previously it was 4, now I send 5 more, so it's 9 packet now. So this way we verify that our site to site VPN is working, and it's sending the traffic through public IPs to the other side. And we verify through Wireshark and also through CLI. And more detail we will see in the upcoming videos.